Hello everyone. Today we are going to discuss about ANOVA for two-dimensional data or ANOVA two classification data. So first of all, ANOVA is analysis of variance. So today we'll learn how to calculate the ANOVA for two-dimensional data, and also we'll see all the formulas, and also we'll solve a problem. So today we are going to discuss about a problem for ANOVA for two-dimensional data. So while coming to as we can see here. So as we can see here, n is the total, n is the number of rows, n is defined as the number of rows and number of columns. It is calculated using number of rows into the number of columns. So basically the data will be given is the number of rows and number of columns. So as we can see here, n is the number of rows and then into the number of columns. So basically the number of rows are the observations present in a row. So number of columns is present in a column. So into the t, that is the total. The t is calculated using sigma x1 plus sigma x2 plus sigma x3. So while coming to the sum of squares, that is sum of squares of columns. So first of all, here we'll consider as the number of observations in a rows are 3 and number of observations in a columns are 3. So sum of the square of the columns would be sigma x1 whole square by n1 plus sigma x2 whole square by n2 plus sigma x3 whole square by n3 minus t square by n, where n is the total and n is the number of observations that is calculated by using number of rows into number of columns. And while coming to the sum of squares of rows, sigma t1 square plus n by n1 plus sigma t2 square by n2 plus sigma t3 square by n3 minus t square by n. So there are only three. So here we are taking only three observations. So we have only three up to 3. If there are 4, we also have sigma x square x4 by square by n4 or sigma t power 4 t4 by t4 whole square by n4. So while coming to the sum of squares of total, that is sigma j xij whole square minus t square by n. So xij is the number of is the observations of the rows. So these are so we'll have the sum of the observations minus sum of the observations of the sum of squares of observations minus t square by n. So while coming to the error, that is sum of squares of error, it is calculated using SST minus SSC plus SSR, that is sum of squares of total minus sum of squares of column plus sum of squares of rows. So while coming to this MSC, that is mean square of column, that can be calculated by using sum of the squares of columns by columns, number of columns minus 1. So while coming to the MSR, that is mean square rows, it is calculated by using sum of squares of rows by number of rows minus 1. So next one is the mean square error, that is calculated using sum of the squares of errors by number of columns minus 1 into number of rows minus 1, that is C minus 1 into R minus 1. So while coming to here, here we consider the F distribution. So F calculated for this we use the formula, that is mean square column by mean square error or mean square error by mean square column, that is F calculated value. So while coming to the F tabulated value, it will be have, so default, if they did not give any level of significance, we took default as a 0.05. So here F tabulated is equals to F 0.05 of C minus 1 comma C minus 1 into R minus 1. So this is the degrees of freedom which we will go through in the table. So the next one so this is for columns. So next one, for while coming to the rows, these are the F calculated and F tabled values for the rows. So now let's go through. Now let's go through this. Let's go through the. Let's go through this. Let's solve a problem. So here the problem given is a farmer applies three types of fertilizers on four separate plots. So as we can see here, they are given about two-dimensional data. That is three types of fertilizers and four separate plots. So this is the ANOVA for two-dimensional data or ANOVA two-way classification. So next, the figure on the field for acre are tabulated below. Find out the plots are materially different in fertility also. If three fertilizers make any material difference in field. So basically here we have to find if there is any material difference in the in the yields or any fertilizers. So for this we have to check the null hypothesis and the alternative hypothesis. So here are the given table. So here are the three fertilizers and the four yields. So we are considering the fertilizers as A, B, C, and D, and the yields as A, B, C, and D. So fertilizers are these three, and they have also given the values. So while coming to the solution, here we study about two parameters, that is plots A, B, C, D, and the fertilizers F1, F2, F3. So we can easily say that this we have to apply the ANOVA two-way classification of data. So let's go further. So as we see in the formulas before, first we will calculate the n and d. So as we see here, as we before seen that n is the number of rows into number of columns. So basically here there are given three fertilizers and four plots. That means 3 into 4. N value would be 12. N value would be 12. So while coming to the sum of squares of columns, as we can see here, as we can see here, as we can see here, first step of solving the problem is first that is null hypothesis. So where the plots, those are A, B, C, D are equal, and the fertilizers F1, F2, F3, F4, if this condition is satisfied, then it is null hypothesis is accepted, that is effect of three fertilizers are same. So while coming to the alternative hypothesis, the effect if the plots, those are the plots named as A, B, C, D are not equal, and the fertilizers F1, F2, F3, F4 are not equal, only three fertilizers F1, F2, F3 are not equal. So then we say that effect of three fertilizers are not same. So the level of as we can see here in the question, they didn't give any level of significance value. So by default, the level of significance value is 0.05. So as we said before, the number of rows are 3 and the number of columns are 4. So the n value would be number of rows into number of columns, that is 12. So while coming to the total value, that is T value is equals to sigma x1 plus sigma x2 plus sigma x3 plus sigma x4. That is, first we have to calculate the sum of the x1 column, sum of the x2 column, sum of the x3 column, and sum of the x4 column. So we can see here sum of the x1 is 21. So sigma x2 is 15. Sigma x3 is 24. Sigma x4 is 24. So T would be 21 plus 15 plus 24 plus 24. That is 84. So while coming to the CF, that is equals to T square by N, where T is equals to 84 and N is equals to 12. The value would be 588. So while coming to the sum of squares of columns, the formula would be as we discussed before. Here there are four fertilizers. So the formula would be sigma x1 whole square by n1 plus sigma x2 whole square by n2 plus sigma x3 whole square by n3 plus sigma x4 whole square by n4 minus t square by n. So by calculating these values, we get sum of squares of column as 18. So while coming to the sum of squares of row, so that formula would be here. There are only three fertilizers. So the formula would be sigma t1 square by n1 plus sigma t2 square by n2 plus sigma t3 square by n3 minus t square by n. So while substituting a value, we get sum of squares of row is 8. So while coming to the sum of squares of total, that is square of sum of square of every each and observation minus t square by n. So this so sum of all the total observations, that is 6, 4, 8, 7, 6, 6, 9, 8, 5, 10, 9. So sum of the square of these and sum of these observations minus t square by n would be our sum of squares of total. So while coming to the sum of squares of error, the formula is sum of squares of total minus sum of squares of column plus sum of squares of rows. That is sum of squares of total is 36 minus 18 plus 8, that is 10. That would be 10. So while coming to the mean square of column, so the formula of the mean square of the column is sum of squares of column by column minus 1. So that would be 6, and the mean square row, that is sum of squares of row by row minus 1 is equals to 4. Sum of squares of error, that is sum of squares of error by row minus 1 into column minus 1 is equals to, the value would be 1.6666. So while coming now we have to check the calculated value and table value, and we have to compare, and we have to decide whether the null hypothesis is accepted or rejected, or the alternative hypothesis is accepted or rejected. So while coming to the f column calculated value, the formula would be mean square calculated by mean square error. So value is 3.6001. So while coming to the f row calculated, that is mean square row by mean square error, that is 4 by 1.6666, that would be 2.4009. So this is column calculated value and row calculated value. So we'll see the tabled values. So the tabled value, according to the formula, we have to check the 3 and 6. So in the table, at the in the table at a value 3 and 6, the f distribution value would be 4.76, and in the f distribution table, the value that is at 2 and 6 at the 2 and 6, the value would be 5.14. So while comparing f column calculated and f tabled value, f cal f F column calculated value is less than F column table value. So basically, when the calculated value is less than the table value, so the null hypothesis is accepted. That is, alternative hypothesis is rejected. As we seen before, is null hypothesis accepted? That is, all the plots are equal. Then we can say that all plots are equally affected, are equally effective. So now while comparing the F row calculated value and F row table value, F row calculated value is less than the F row table value. So as we discussed before, it is if the calculated value is less than the table value, then the null hypothesis is accepted and the alternative hypothesis is rejected. So F row calculated value is less than FR table value. So the all F1, so F1 equal to F2 equal to F3. So all the fertilizers are equally effective. So so the So as they asked the question to check whether it is equally effective, that is, if make any material difference. So we have seen that they are equal, so it doesn't show any material difference in yields or any in fertilizers. So this is information about ANOVA two-way classification and a problem. Thank you.